Let's talk about functions, what they are, how you write them, and their benefits. To understand functions, let's take a simple example. In module 1, we had computed the number of moles of 60 picograms of DNA. And to do this, we had assigned a variable denoting the number of grams. So this is 6 times 10 to the power negative 11. And then we had the length, a variable that held the length of the DNA molecule. And then we computed, given that one nucleotide is approximately 650 Daltons, we computed the weight in grams of 1 mole of this length. So 650 times L gives the weight in grams and of 1 mole. And then if we divide the grams by the weight of 1 mole, then we get the number of moles. Now, some things about this can change and other things don't change. So for example, if we change the number of grams, it's possible that we may want to compute 60 nanograms and not 60 picograms. Similarly, the length of this can change. Perhaps we want to compute the number of moles of the human genome, and in that case it'll be 3.2 billion base pairs instead of 1,000 base pairs. The things that are invariant or that don't change are how you compute the weight in grams from the molecular weight of a nucleotide and the length of the DNA molecule, and the computation of the number of moles by dividing the total weight in grams by the weight in grams of one molecule of the DNA. Now, let's say we were to repeat this calculation with different input amount of DNA in grams or a different molecule with a different length. One would have to basically take this code and copy and paste it, and then go about modifying the code. And there are several weaknesses to doing this, and one is that it's inefficient because we have to copy and paste the same code over and over again. Second, one could make mistakes while we are modifying the code. Instead, a much better way of doing this would be to define a function that carries out this task and call that function instead of copying and pasting our code. And the syntax for defining a function is as follows. So we give a name. So we'll say convert mass to moles. Then we have the assignment operator, and then we say function. And then in the parentheses, we provide the arguments to the function. Now, what things should be the arguments to the function? The things that can change from use to use, in this case, it would be the weight of the DNA, the grams, and the other thing that can change is the length of the DNA. Those are going to be my arguments. And those steps of the calculation that are invariant, that don't change, are going to be conducted or carried out inside the function. And therefore, I will take the length and compute the weight in grams of one molecule of this DNA, and then I will calculate the mass, the number of moles from the given weight in grams divided by W, which is the weight of one molecule of the DNA. And then we use the return statement to return the computed value. And so basically a function takes inputs and then you return an output. And now when I execute this code chunk and look in the environment tab, a new item has appeared, which is under functions, convert mass to moles. So this function is now available, has been loaded into the memory, RAM, and made available in the R environment. And now I could call this function, whether it's in this code chunk or a different one, to actually compute, convert mass to moles. And to give an example, I can convert mass to moles of, let's say, 6 picograms of a molecule of length 1000, and that's the number of moles. Now if I wanted to, in some other place of the code, needed to compute what is the number of moles in 60 nanograms of human DNA, then I could do convert mass to moles and just change the values of the arguments without having to copy and paste all the code. So we'll do 60 nanograms, and the length is going to be the length of the human genome. And we can run this code chunk, and it's telling me how many moles there are in 60 nanograms of human DNA. So functions offer many advantages, and the basic role is they allow you to reuse the code. So the advantages are, as the requirements change, so let's say we wanted to change this calculation in some way, you only need to update the code in one place, which is inside the function, and you don't need to go and update the code in all the places you're calling the function, because the function is like a black box, and where you're calling the function, it doesn't really matter how the function works internally. So let's say there was a mistake that we discovered in this calculation, and had we copy and pasted this code in 100 different locations in our software, we would have to go and fix the code in 100 different locations, 100 different times. But since the code is since the code is in the function, we only need to change the code inside the function, and we don't need to modify any of the other locations. Okay. You reduce the chance that you make mistakes when you copy and paste. When you're copying and pasting the same thing over and over again, you may update the variable in one place but not in another, and that can lead to bugs and unpredictable results in your code. It makes it easier to reuse your work from project to project, and that means if I have one piece of code that I'm writing that needs the conversion of mass of DNA into moles, I can take call the same function in another project, which also has the same need, and so you increase your productivity over time. Also, functions allow people to share code with each other, and once again increase each other's productivity. So for example, libraries like ggplot and dplyr are just libraries or collections of functions that other people have made and are sharing with us, allowing us to use their work. And finally, you can give your function an evocative name that makes your code easier to understand. So like here, we named the function convert mass to moles. So when we call that function, if somebody is reading this line of code, they can tell what is being done, that is, the mass of DNA is being converted to moles, just from the name of the function, without knowing what code is there inside the function and how it works. And so it makes it really easy to understand what step is being performed. Now, very often, even though it's good to provide the flexibility by giving arguments so you can change the behavior of the function, sometimes the values of the arguments don't change. For example, I could be working in a lab that only deals with human cells, and therefore the length argument is not going to change from time to time when I call this function. And although it's possible that rarely we do some vector cloning when the length argument will not be the length of the human genome. So in order to simplify the usage of functions but also provide the flexibility, it is possible to define default values of arguments. And we will redefine this function now. And in the function definition, where we had the length argument, we can say len equals 3.2 E9, which or 3.2 billion base pairs, which is the length of the human genome. And so this value will become the default value, which means if I call this function, and first, of course, I have to run this code chunk so that this function definition is loaded into memory in the environment. But now, if I call this function with grams, let's say 60 nanograms as we did before, but omit the len argument, by default, the len argument will take the value 3.2 billion, and we get the same answer as before for the number of moles there are in 60 nanograms of DNA. Now, it's possible to call functions from anywhere in the code, including from within other functions. And this allows us to use a divide and conquer strategy, breaking a task down into simpler pieces and writing functions to accomplish those simpler tasks, and then combining them in other functions that call those functions that perform the simpler tasks. So to see an example, let's write a function to convert grams of DNA into the number of molecules. And what we want to do is we want to reuse the function we defined previously, which is convert mass to moles. So we will go ahead and write this function, and so we will say convert mass to molecules, and then we have the assignment operator function, and we will say grams, and length will be the length of the DNA molecule, and again we'll give it the default value as the length of the human genome. And then we have the curly braces, which contain the statements executed when the function is called. And the first thing we want to do is we want to determine the number of moles in this mass of DNA. There's so many grams of DNA, and instead of computing that de novo all over again, since we already have a function called convert mass to moles, we can call that function and assign the value to this variable moles, and we will pass the grams argument to convert mass to moles, and also the length argument. Now that I have the number of moles, we can compute the number of molecules by multiplying with the Avogadro constant. So moles times 6.023 E23, and we should return this output num moles. And now the function is complete, and I can run this code chunk. And if I go in the environment, now I have a new function called convert mass to molecules, which will determine the number of molecules of DNA. And I could invoke this function in a different code chunk. It could also be in the same code chunk, but it can really be anywhere. And we could say grams equals 60 nanograms, and then we want we don't have to pass the length argument. Let's say we were just trying to determine how many human genomes 60 nanograms of DNA has, and we can run this, and there are 17,374 human genomes in 60 nanograms of DNA.